Hey folks, welcome to Advent of Code in F#, day 6. Yesterday we were working a bit on part 2, but then we ran out of time and I have not found the time to continue, but I have an idea of how to do it in a reasonable amount of time. That'll be for later. Let's just dive into day 6 first and let's stick with the program. Wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you do not see anything beside lots of water and the small island where the ferry has docked. As you try to figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races, open to the public. Grand prize is an all expenses paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race, instead you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. You will get a fixed amount of time to travel as far as we can, okay. As part of signing up, you get a sheet of paper, which is our input, that lists the time allowed for each race and also the best distance ever. Okay, to guarantee you win the grand prize, you need to make sure you go farther in each race. So you need to beat every record, okay. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total time. Okay, optimization problem. You can only hold the button at the start of the race and boats do not move until the button is released. Alright, so we get time distance numbers. This document describes 3 races. First race lasts 7 milliseconds, the record is 9 millimeters, and onward. Every column is a race. Our toy boat has a starting speed of 0 millimeters per millisecond. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases. The speed increases by 1 millimeter per second. Okay. We only have a few options for the first race because there's only limited time, that's true. The options are don't hold button, hold for 1, move for 1. No, hold for 1 and then move at 1 millimeter per second, so we move 6. Okay, yeah, it's a more interesting optimization problem. Hold for 2, then we go 2 every millisecond. We have 5 more. Okay, yeah, makes sense. And there's some winners in here. Current record is 9 millimeters. There are actually 4 different ways to beat the records. Okay. And we need to determine the number of ways to beat the record in each race. And then we need to multiply. That's a weird part 1. Will part 2 just be determining the minimum amount? No, let's not skip ahead. Okay, so I think I get what's going on here. Naive approach first, of course. Maybe let's first take a look at the actual input to see how big. Oh, it's very doable. That's very doable, I guess. Yeah. I'm gonna put my input somewhere safe. I'm gonna grab the example. And let's start hammering away. Problem is very small. It's not even worth a parse, but let's quickly do a parse. So we need to do something for every race, that's every column, and then we just calculate all the possible durations. We start pressing a button, we calculate how far we get, and then we see how many times we beat the records. Doable. Let's go. I'm gonna parse into some lightweight types. Yeah, something with a time and a distance. So a tuple with a time and a distance. Let's call that a race. Yeah, let's call that arrays. Time in milliseconds and record in millimeters. But let's not worry too much about units just yet. And we need to parse the columns, right? Every column is a different race. Okay, so let's split all the lines. Let's split all the lines in the example on white space. Why not? So let's split on white space and let's remove everything white, I think, or every white space. I think then we already have what we need. There we go. And then from the first element to the last, we just loop over these to grab our race data. And then we say for index in 1, 2 lines. It's always 2 lines, right? Yeah, it's always 2 lines. Okay. But yeah, let's do it that way. So lines 0 list map. And we grab yeah. Okay, so I'm doing a lot in my head and not talking a lot. I'm going to iterate over the first line. I'm going to skip the first part because that's the time, the title. And I'm going to map over all the rests, and I'm going to do a map I, which indexes. So it's the same as a map, but you get the index for free. And then we can grab that part in lines in the next line. And I'm going to do skip later, so I don't have to calculate offsets. And this index is the same as the index in the first line or the second line. So lines 1 is the part we need from the other line, and first is the part we just parsed. So I think this is correct. And if we skip 1, we drop the titles. Lines is not defined. Oh, I forgot to send it to my interactive window. Why does it think lines is an array list? Oh yeah. It is an array list. List of string arrays, because we split. It's a list of string arrays, yes. So this is a string array. So if we just do array.map or sequence.map, that should all work. There we go. Almost correct, except that we don't want the entire second line. We need to index into the second line, and that is the I we have not been using. There we go. So 79, 1540. That's not correct. Yeah, that's correct, and 3200. So yeah, that looks correct. I'm gonna wrap it into the type we just defined. So that's time distance tuple, and let's wrap it into something that specifies that it's a time and distance. And we need to parse them into integers, or into numbers at least. So let's do that as well, and then we can get started on the algorithm. There we go. Could you not? I think my auto formatter is breaking my code. Though I'm not sure why. Okay, I'm gonna use the different syntax for indexing. Why doesn't it like indexing anymore? You're supposed to be able to do it without the dot, but maybe the 2D thing or the spaces are messing it up. Okay, but we parsed our input. Now let's calculate how many times we can win each race. For that, we need to take a look at all the potential button press times and then the speed we have. So how do we find out all button presses if we just do the naive thing, which is doing exactly what this example says? We go from not pressing it all to pressing it the whole time. So that's just a range. So what are we going to do? We are going to calculate all the total distance traveled. So let's write a function, total distances, that maps a race to all the total distances. So we have a function that takes a race and it returns a list of whatever distances. And for that, we can take not doing anything and doing the maximum allotted time. And these are all the possible button press durations. And we can do a total distance. We can calculate the total distance for this duration in this race. And then our function enters the fray. There we go. And that should just return a number. And because it's the last argument, we can clean up this syntax a bit. And let's go. So the total distance for race and duration. So we calculate speed first. That is actually the duration. So that's not the hardest complication. Computation. And then we see how much time we have left. So race.record. Let's help the compiler again. So race.record minus duration, that's how long we have. And then I think we can just say, why is the minus not working? Okay, and then we can say our current speed times the allotted time we have left is the distance we travel. Let's see this in action. So for the first one we have 0, 8, 14, 18, 20, 20. That's not correct, right? 0 is correct, but then we should have 6 millimeters. Where's the error? And why do I have 1, 2, 3? Oh yeah, we have 3 races. Okay, so there's a bug in there somewhere. Let's take a quick look. Hold the button for 1 millisecond. Then the boat will travel at 1 millimeter per millisecond for 6. That makes a lot of sense. Where would 8 come from? 4 times 2? Now let's print it out. I'm not seeing it. So let's do some debugging. And I'm gonna... No, let's just do some quick debugging here. We're just printing out the races. That's not very helpful, right? But we can already look at the I that's coming in. That is the duration. Duration goes from... Why are we looping over duration? Because it's actually the race time. is the press duration, right? I'm confusing myself a bit. So that's how long we press the button. Okay, so that's just a name change. That does not change my idea of whether or not this is correct. So given a race and given how long we want to press a button, how do we calculate how long we press? That looks correct. It should always be a positive number. So let's see, from 0 to 7 also appears to be correct. Let's print out the output for this thing so we see a bit more. And let's also print out the result. There we go. Where's the problem? If we don't press, we end up at 0. Yeah, if we press for 1 second, we're at 8. So yeah, our total distance function is wrong. And there's only 1, 2, 3 numbers. How can I not see the problem here? So if we want to press for 1 millisecond, our speed becomes 1. That is correct, right? And it will travel for 6 milliseconds. Record is 9. Oh, record is 9. We don't need to take a look at record. We need to take a look at the time to calculate remaining time. Oh, this is an early in the morning kind of bug. My apologies. So 0, 6, 10, 12, 12, 10, 6, 0. Yeah, so that's correct. Whew. So we have distances. What do we need to do with those distances? We need to see how many times we actually beat the records. Yeah, let's just build a pipeline. So over all those distances, let's map over them. And let's filter. Oh, we still need to race for that, right? Yeah, so I'm gonna wrap our total distance calculation or the results into a tuple, so we keep track of the original race next to its total distances. So now we have the original race and all the distances we could get, and now we can map this on something else where we filter out or where we count the number of scenarios where we beat the record. So that is keep the race, keep the distances, but filter those out. Beats record, let's call that a beats record predicate. And it beats the record in this race because it's a distance that we get. Yeah, so race distance. Why is my compiler complaining? Because we were missing some parentheses. There we go. So when does a distance traveled beat the record? When the distance is better or better than or unequal? What's the... What are we looking for? At what actually winning or beating the record means? Beat the record. Well, what's beating the record? Is improving upon the record or matching the record? You need to make sure you go farther in each race. So we need to beat it, so our distance has to be bigger. Yeah, I think this is it. So we have a couple of winning races here. 10, 12, 12, 10. That's 4 different ways. In the second race, we should have 8. And then we should have 9. That's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's correct. And then we have this, and we can just multiply everything together. So that's all the winning scenarios, and then we can just calculate the part 1 result. Let's forget about races, we don't need them. Let's just map out to the length of the record-beating runs. So we can just do this, we can actually just do this. And we can multiply those. That's sequence dot reduce, for example. It's a bit like a fold, but you don't give an initial state. You just assume that the first element in the list is the state, and you go over it. We need to send some more stuff to our interactive window, and there we go. 288 is what we want, and it's what we get. So maybe this should solve part 1 for us. Let me grab my parsing, and let's put everything together. Let's write a parse function. We're going to use this input parameter, and it is a string list or string array. Let's make it a list so our compiler is happy. There we go. And let's build this pipeline out further. There we go. That's it. This is our solve function. And let's run it on the example one more time. We see 288. I am happy. I'm gonna put this in a test after the fact. And we're gonna see whether or not it tackles our input. If my fingers are not frozen. Okay, that's a symmetric number. Is that a good or a bad sign? It is a good sign. Okay, I'm a happy camper. That's part 1 down. Part 2, let's read it first. I hope the bump up is a bit less than what we're used to in the first couple of days. So part 2, as the race is about to start, you realize the piece of paper with race times and record distances you got earlier actually just has very bad kerning. Kerning? Sorry for the white screen. Kerning is a process of adjusting the spacing between characters. Okay, so this is the concept of kerning being applied or not. That's good enough for me. There's really only one race. Oh no, ignore the spaces between the numbers on each line. Huh. Huh, what does this mean? It means we have big numbers. Okay. Now you have to figure out how many ways there are to win this single race. In this example, the race lasts for 71530 milliseconds and the record is this. You could hold the button anywhere. You could hold the button anywhere from blah blah blah. That's only 71,000 ways. That's not that big of a search space, right? How long would the search space be? Oh yeah, the search space is a bit bigger. How big is the search space actually? I'm getting confused by these numbers. Oh yeah, that's because these are only the record beating scenarios, not all possible button press durations. Okay. At first glance, it looks like something that we should be able to do naively, so let's verify. The only thing that actually changes is our parsing, right? Or for the naive approach, at least. Here we have a race array. We don't want a race array. We want the single race. Yeah, so let's take a look at our parser. I'm gonna play around with this in my REPL a bit. So this is the example. Is that true? Yeah. No, it's not the example. Let's grab the example. So I'm just gonna alias input with example, and then when I run code that references input, it takes the example. So yeah, we can get started. So yeah, we have 2 lines here, and we need to smoosh the numbers together. So let's get rid of the time and the distance. We definitely don't need these anymore. And then we can just smooch the numbers together. So we have just the strings, and let's then parse those into an integer. Or let's go to, just as in day 5, let's go to long, just to be safe. So yeah, then we have our 1 race parsed out already, so we don't need all these other things. We can just return the single race, where time is the first row. Yeah, time is the first thing, so that's... And distance is the second thing. It's very confusing to see lines here, and it's a list of UN64, so that's maybe not the right term. Let's call that, I don't even care. Let's call it numbers. We parsed out the numbers. So yeah, this is a new parser. It returns just a single race. And I think most of our code should work, except that we don't need to map. We just have the single race instead of a list. So let's get rid of this wrap. Let's get rid of this wrap. And then we have... Why is this not working? Oh yeah, it's just a tuple. It's a tuple of the race and the distances, because we wrap this thing around. I'm gonna get rid of the wrapping the race around. It's just 1 race. We have the 1 race available. So there we go. Let's grab out race into a variable, which is this thing. This thing, I said grab it out. I extracted the function without actually extracting, so there we go. We have a race, we have the winning scenarios, and we just need to map to how many of those scenarios. Oh no, those are the winning scenarios, so we just need to multiply them, right? Do we? Winning scenarios is like just the 1 list of wins. Is that not just the length? We need the length, right? Yeah, how many ways can we beat the record? So this is, in theory, all we have to do to solve part 2. And even for the example, it's pretty impressive. But it finishes. Can we explain why it's slow? 71503. It is correct approach, or the brute force is working, but it's way slower than I anticipated. We are iterating from 0 to this number, and this number is the top. So what does that mean for our input? Let's parse the input. So this is a bigger number, right? By a factor of... by a factor of a couple orders of magnitude. Let's see how many. 1, 2, 3. So it's gonna take what, roughly 1,000 times longer? I don't think I have the patience to wait for that. Again, it's an optimization problem. Again, we're gonna hit oh, there's overflows happening. There's overflows happening. How can we get to negative? How do we get to negatives? How is that happening? In my mind, we would never have negative numbers, so I'm confused. Let's do that again, and let's take a look at what's happening. Oh, we're parsing into integers still, so I might have thought we were doing longs, but we're not. That's interesting. Why was my compiler not complaining? Oh, because we're parsing into an int here. Oh, jeez. I should stop doing these puzzles in the morning. Obviously, my brain is not ready for this kind of challenge. So, changing the... Oh, with hyperprinting it's actually a bit faster, so let's try to solve it for the input. It was just a lot of printing. Oh, we got a number. Very good, very well. Let's see. Oh, thank you. No hard optimization problem 2 days in a row. Yes, I'm very happy we got this star. So let's recap and see what we did today for day 6. I'm gonna dive into part 1 first. I see that I changed my code for part 1 for part 2. So let me just fix that quickly. Let's drop in our part 2 code and let's revert some. That's part 2. Still not woken up. There we go. And for part 1, let's back out of our changes a bit. There we go, there we go, there we go. Yeah, we did the parsing and we had our test. And we ran it on the input. So yeah, this is part 1. My apologies. For part 1, what did we do? Not much, actually. We parsed, but it was a bit of an overkill to parse for today, to be honest. We could have just worked with tuples and stuff, but we chose not to. How did we approach the problem? We went over all the races, figured out all the possible durations to press the button, so it was pretty basic. It was a literal translation of the problem description. What were some interesting things, or at least I think are interesting for today? That's when you're building pipelines in a functional language, often you need to like enrich data. So you don't just map from type A to type B. Often you need like the original type A somewhere further down the line. You can easily do this if you just wrap your result in a tuple. So here in this case, we had some races and we transformed every race into like a list of the distances you could get by all the different button presses. But we just still wanted the original race, just wrap it in a tuple. And then the next step in the pipeline has access to that original value. That's how I typically enrich my data in functional pipelines. First time we saw reduce. A quick recap, or what is a reduce again? We've seen fold a couple of times, and fold is like the big brother, where you can do all kinds of things. Reduce, the state is the same type as the elements in your array or the elements in your sequence, and it just takes the first element as the initial state. But for the rest, it's just a fold. You can write the fold in terms of reduce and or vice versa. No, you can write a reduce in terms of a fold. I think that much is correct. So they're pretty similar, but not quite. This is the easier of the two, which you see a lot when you're just doing multiplication and addition, stuff like that. That was part 1. Part 2 was actually surprisingly easy today. where we, instead of iterating over multiple races, we have one very big list, which cost us a bit more CPU cycles, but not that much. So I'm very happy we got our stars. I'm gonna take a quick break and then take a look at day 5 part 2. But for now, I hope you enjoyed this Advent of Code in F# day 6, and I'll see you again tomorrow. Bye bye.